Okay, no problem. Listen. The topic is current carrying conductor or wire, straight wire. Conductor in a uniform magnetic field. If I place a current carrying conductor, in uniform magnetic field, what will happen? What will happen to the current carrying conductor? Let's say this is uniform magnetic field here. Yes or no? This is uniform magnetic field present here. Listen everyone. Here a conductor is placed and it is conducting what? Current, no? Yes or no? Current carrying means it has some current. Yes or no? It has some current, means current is flowing through this. Yes or no? I current is flowing through this. Let's say. Clear? Okay. I current is flowing through this conductor. What does it mean? It means charge is flowing in opposite of this. Yes or no? Charge is flowing opposite of this or no? Means charge what? Electrons, no? Electrons are flowing opposite to this. Clear? Clear to everyone? Okay. And magnetic field is in this direction. Yes or no? Yes or no? Tell me, force exerted on one electron. Magnetic force. This is V, na? Magnetic field. Okay. Force, magnetic force exerted on each electron is, what will be the magnetic force? I am taking F, small f. Why? Because of 1, na? What will be this F, magnetic force? You have formula, na? What is this? Q, V cross B. Yes or no? Q, V cross B. Is it negative sign? Q is negative, no? So, first calculate the magnetic. Okay. You will have the direction, don't worry. Q, V cross B. V cross B. V what? V D na actually. Drift velocity, na? Yes or no? Currents are moving, electrons are moving with drift velocity, na? Yes or no? Okay. Is it for one electron, na? Yes or no? I am considering L length of this, means DL length of this. This is DL length. Okay. From here to here it is DL. Okay. There is no conductor, na? I am just considering DL length. Okay. And area of cross section of this is A. Okay. How many currents will be there inside this conductor? If electron density is N, means total number of electrons equal to what? N A L. Yes or no? N A L, na? Means why AL is volume of this conductor or no? Okay. Now I want to calculate total force. Means total force on the conductor. Means how many electron it will be, means this will be multiplied with total number of electrons, na? Yes or no? This is for one electron, na? How many electrons are there? These many. Yes or no? Okay. Means total force will be equal to F N into F. Yes or no? This is N actually, no? Yes, no? F equal to, what is N? N A L. What is F? P V B cross B. Is this clear to everyone? tell me, I want to convert it into I. Do you remember? Sorry. I equal to, what is this formula? Any VD? Okay. Is there any VDA? Any VDA? Any VDA? Yes or no? And what is left? A is left. Oh no. L is left. Yes or no? L. V is not there. Cross B. Yes or no? Actually, these are scalar, na? Actually, this is scalar, na? Yes or no? This is only vector. So we will multiply either in forward or in backward. It's okay. This whole complete quantity is vector. Clear? With cross with another vector. Yes or no? What is this? What is this actually? I. Can I take it DL because it was DL, no? Don't take L here. It was DL, no? Yes or no? It was DL actually. Yes or no? It was DL. Let's take DL. Clear? Means I DL. Is it vector quantity? Is it a vector quantity or no? Tell me, everyone. Yes. I will have to put vector here. Already told you current element. IDL is what? Current element. Means DL have magnitude, I has current. DL have direction and I have what? Magnitude. That's why they made IDL, and that is vector quantity. Element. Current element it is the into B is the force acting on the what? Current carrying conductor. Yes or no? Vector IDL cross B is the force acting on the current. Tell me the direction of this force here. You got the direction? Means IDL cross B. IDL cross B. Till here you can get confused. What? Where? Where is the velocity? This way. Yes or no? In this direction? Where is VD actually? In this direction? Where is magnetic field? V cross B, na? V cross B. This should be the direction, na? Yes or no? But due to electron, what are these? Electrons, na? What should be the direction? Into the plane. Into the plane. And calculate from here. Ideal means I will consider the direction of current, na? This is the direction of current cross B. Ideal cross B. We got the same direction or no? Yes or no? Yes. Don't get confused. Current is moving in this direction. It should be like this. It should be up. No, because of electron, it will be into the plane. Clear na? And don't go with the basics. Go with the formula. Yes or no? You can have the exact answer na. Ideal cross B. Ideal means upward. DL B means there. Into the plane. Yes or no? Yes. The force will be into the plane, and that's why I'm representing it cross here. This is force, no? Force. Clear? Copy this. Clear now? Yes. Okay, copy this. Copy properly. DL is displacement vector here. Okay. If wire is okay, I will talk it later, but first copy this. Actually, derivation is not in your syllabus, but if I will not derive you can't get the actual concept behind every theory. If you don't have the concept, you can't solve the theoretical questions. whatever questions I have given two questions now, there were only theoretical thing and there were only concepts. Using that concept, this was the concept actually. Yes or no? That's why I did theory part here. Because for theoretical questions, you will have to be good in conceptual understanding. Yes or no? If I am talking about this vector, so take vector. Sorry, take vector form. This is vector na cross product. I am not taking magnitude of this. This is vector and take vector. Okay, no problem. Now, I want to calculate the magnitude. What will be this magnitude? F equal to, and tell me, this was the for DL na. If you have the L entire length, you will put L here. Yes or no? If you have that, if you know the length, if this is the length, I took this length DL na. If you know the entire length, you will put L. Yes or no? In place of DL, the magnitude will be BIL for L length. Yes or no? Because IL will be what? D means DL is will be L, I is I, B is B, and what is, because of cross product it will be have sin theta. What is in scale means magnitude scalar form. Scalar form. Okay. This is how we will have to calculate. And now, if tell me everyone, listen everyone. What if the current element is like this? Current is moving like this. Now, this is the end points, okay? And magnitude, magnetic field is moving. Magnetic field is in this direction, okay? Of B, and angle is making angle what? Let's say this is 30 degree. Okay. Okay. And current is 5 ampere. B is 2 Tesla. Okay. This is 2,3. No, 2,0,0. This is don't take 2. This is 0,5. 0,9,0. Okay. Yeah. Find force on the current element. Current carrying wire. Force on the current carrying wire. What will be the force? Tell me. What will be the force? I am giving you hints here. D. What will be the L here? Length. Length will be the displacement. Okay. 9 minus 5. 4. Okay. Don't take the length of this curve because initial DL is what? Vector quantity. And I have told you if DL is vector quantity, I will take displacement. What is displacement? The distance between shortest distance between initial and final point. It is initial and final. Put the value of displacement only. Clear or not? Now you can solve the question. What is the answer? 20 what? Newton. How you can solve this question? Everyone. Solve everyone. Try this. If the wire is not straight, how you will apply the answer? Formula. You will have to take DL in the form of displacement. Na? You will take difference. You will take the difference of initial and final positions. shortest length. I'm solving this question. Solve. Okay. I got F equal to BIL actually. Yes or no? Sin theta. BIL sin 30 na? Yes or no? Yes or no? Yes. Okay. Why sin 30? I told you actually if I take vector form, what will be this? IDL vector into D. Yes or no? I am talking about ideal current. Although current is flowing in this direction, what is the DL direction? Is it this? Yes or no? That's why I will take this direction. What is the angle between them? What is the angle between them? 150. Yes or no? What is the angle between them? I already told you. Always choose the angle between two incoming or two outgoing rays. Yes or no? Now it will be I L B sin 150. Yes or no? What is I? 5 ampere. What is L? 9 minus 5. 4. What is B? 2 Tesla. What is sin 50? Sin 180 minus 30. Sin 180 means sin will be sin. 180 minus 30 means second quadrant. Yes or no? Sin positive. Sin 31 by. Is it clear to everyone? Yes or no? Although you got correct answer, once if you sometimes you can get wrong answer by considering 30 only. Clear? This is the case where you can consider 30 or 150. It will be safe. Okay. What is 20 Newton? Yes or no? Not this answer, na magnitude. 20 Newton. Yes or no? So, force between straight current. Huh? Current conductors. What is this? Conductors. What do you do with this? What is this any problem? Oh, it's not straight. What about dislocation by plane due to plane? Yes. Okay. It's okay. Do treatment of that. Okay. Copied? Tell me. I want to calculate force between two straight current carrying conductor. Means if you have two wires. Generally you can have, yes or no? If two wires are like this, both have same direction, both can have opposite directions. Yes or no? These are parallel actually. Current carrying straight conductor. Force between two current carrying straight. Current straight. Force between parallel straight current. Okay, no problem. Two parallel. Okay, two parallel straight current carrying conductors. Okay, this is the topic. Now, I am drawing the parallel conductors. Let's say this is parallel conductor, this is parallel conductor. I am considering the distance between them is very less compared to the length of the conductors. Okay, this is made of infinite length. Okay, means if the distance between them is Very less. It will considered as infinite. Yes or no? Draw larger wire so that you can have idea these are infinite. The distance between them is, let's say, d. What is the distance between them is d. Now game starts. The direction of current is same. I am taking case 1 same. Okay. If the direction of current are same, tell me what will be the magnetic field here. This is I1, this is I2. Okay. Yeah. You have right. I will consider right hand thumb rule. Means due to this wire, which direction will be, in which direction the current magnetic field will be? Inside, na? Yes or no? This is B1 or B2? B1. Yes, na? What about this? Outside or inside? Outside, na? B2. Yes or no? Now, game starts. This is B1. And I current is flowing with this current, na? This is the case, na? You have magnetic field, na? Here. Don't go there. Imagine here. You have magnetic field here. Yes or no? If you have magnetic field and current carrying conductor, it will have force on this conductor or no? Yes. Which direction force will be? Vector ideal cross B. Yes or no? What is ideal? This is I, no? Ideal is in upward direction, no? Is this ideal? Vector I2 dl. Yes or no? Yes or no? Yes, no? Ideal in upward direction. I am considering of L length it is. Okay. Ideal. What will be the force? Ideal cross B. B is inside. Ideal cross B. Force will be in this direction. Yes or no? Tell me. Yes. This is the force on 2 due to 1. No? Yes or no? What will be the force on 2 due to 1? This will be B what? 1 I L, no? L of what? Let's say DL of what? Second one DL 2 or just I'm considering DL length of this, DL length of this. Okay. Don't need to DL1, DL2. Okay. I'm considering DL length. I don't know na infinite wires are there. Clear? DL. What will be this expression actually? What will be this expression actually? D means mu naught I1 upon 2 pi D. Yes or no? What is this? Is I1 now? I2. Sorry, I2. This is I2 now? Here. I2 D. F21 it is. I am taking DL in this direction. Why DL I am taking in this direction? I will tell you later. If this is of greater length and this is of lesser length, I will tell you later. First, mu naught I1 I2 upon 2 pi D. We got equation 1. Force per unit length on this. Yes or no? Now, let's talk about this. Force on second wire. Force on means first wire due to second. Yes or no? What will be the force on? If this is magnitude direction, we already know. Don't write the direction. I am taking magnitude now. Okay. Force on first due to second. What is this? B2 I1 what? DL na? I am talking about DL. What is this? What is this? This is what is this? Mu naught I2 upon 2 pi D. Yes or no? I1 DL. I am taking DL here. DL. mu naught I1 I2 upon 2 pi d. Equation 2. Both are same. Both are same or no? Yes. If I would have been taken L1 here, L2 here, L1 here, okay, it would have been different, na? Yes or no? That's why I divided this value with this. It may be different. Divide them. What will be this force per unit length? Now it is what? Means force per unit length on this wire or force per unit length on this wire will be same. Just like two charges. Yes or no? Charge on is this charge or this charge? Both will have same magnitude. Yes or no? It irrespective of magnitude of the charge. Yes or no? If this is 2 coulomb, this is 4 coulomb. Which will have more force? Same force. I already taught you now. Why? Because there is K, Q1, Q2. The product of Q1 and Q2 is same now. 2 into 4 is 8. 4 into 2 is 8 now. Force will be same now. Here the force on this wire or this wire will be of same magnitude. Why? There is I1, I2 now. Yes or no? This is product of both now. Whenever product of both is there, it will be same. Clear or no? That's why I divided L length. Means here forces are not same. Force per unit is same. Force per unit length is same. Force per unit length are same. Right. Force per unit length are same. Means same forces are acting on each other. Yes or no? If I am talking about this, about this one, F 2 1, no 1 2. Yes or no? And both are attractive or repulsive. The forces are attractive or repulsive? Huh? Attractive, no? They are acting towards each other or no? When current will flow in the same direction, they will attract each other, and when current will flow opposite to each other, they will repel each other. I will explain that too. They will repel each other. Yes or no? Is this behaving like two magnets or two opposite charge? Yes or no? But in charge, there should be opposite polarity. But in current, there should be same direction. Yes or no? For attraction, they should be of same directions. Clear or no? Remember this. The question, objective questions can be asked directly. They will attract when they have same direction, opposite direction, perpendicular to each other. Yes or no? They should have same direction for attraction. Clear? Okay. These are same. Now, can we write like this from equation 1 and 2? 1 and 2. What is this? F 1 2 by dl. F 2 1 by dl is equal to what? Mu 1 mu naught I1 I2 upon what? 2 pi d. If you are asked to calculate force on one wire due to the other, what you will have formula? F12 equal to mu naught I1 I2 upon 2 pi d into what? Due to the force on 1 due to 2 now, you will take length of 1 on which you are asked to calculate force. On which you are asked to calculate force on 2 now, you will have 2. Means this will be L1. Yes or no? Yes or no? There were L1 divided now. What about F2 1? Force on 2 due to 1. This will be same mu naught. Not forces are not same. I1 I2 upon 2 pi d. This quantity is same and multiplied by 2. Forces are not same. Not same. But force per unit are length. Force per unit length are same. Yes or no? Not same. This is same. Clear now? Remember this. Don't get confused. Okay, copy this. Yeah. Now tell me, what will be the directions when direction of electric current are reversed? Means opposite directions. They will be repulsive or attractive. Draw the figure if you can in rough copy. And imagine the magnitude and directions. That's why digital boards are more easier. I click here, everything's set up. Yes or no?
Yes.
But we didn't approach to that level right now. Okay. Okay. Come to this level. Come to this level. These are two wires, right? One is in opposite direction, upward direction, one is downward direction. Okay. Now, I'm telling you. Magnetic force due to this, magnetic field due to this wire on this wire is what? The inward, no? Inward means into the plane. Yes or no? Means into the plane. Clear? Now, what will be the force on this wire? Ideal. Ideal means this. Means what? This is the direction of the ear. This ideal. Ideal means this direction, na? I1dl. Yes, na? Ideal cross B. Yes or no? Means ideal cross B. Force will be here, na? F1, 2. Yes or no?
Yes.
What about this? Due to this, magnetic field is what? Into this. Yes or no? Ideal is downward. Ideal cross B. Ideal cross B. Means it will be in this direction F2, 1. Yes or no? Yes or no? Means repulsive or attractive? Magnitude will be same. Or whatever the derivation we have done, magnitude will be same. But repulsive. When both are in opposite direction, it will be repulsive. Repulsive force per unit length. Here, attractive force per unit length. Attractive force per unit length. Per unit length. Why I am writing per unit length? Because you understand 1 unit length is equal. Otherwise, it will have different values, na? F12 and F21 different here, but per unit length they are same. I am giving you a question here. Copy it, no? Do a question. Do a question. Question is that a straight infinite wire is this. Okay, this is infinite wire. Current flowing through this wire is in this direction. Let's say same current flows or I1 current flows. Another conductor is placed above it. Okay, having what? Opposite direction. Let's say same current. No? It will have same current. It's okay. Same current. At a distance what? At a distance what? H height. Means this is infinite wire. This is finite wire suspended over it. Yes or no? Suspended over it. Now, if both are in opposite direction, what will be the force between them? Repulsive or attractive? Repulsive. It will suspend now. It will not come down because it will repel each other. Yes or no? At a point h height, it got suspended. Means the force on this is 0. Yes or no? Why? Whatever the magnitude of this force, mg will be equal to what? Means F. Yes or no? Force, magnetic force. Yes or no? If I am taking L length of this wire, okay, mass of this wire is M. Yes or no? L is the length of this wire, M is the mass of this wire. At a height h, it is at equilibrium position. What is this? Equilibrium position, na? And tell me, is it stable equilibrium or unstable? For stable and unstable, you just need what? Just displace that a little bit. If it is retaining its equilibrium again, it will be stable equilibrium. If it is displaced slightly, it will not retain that. It means it is in unstable. For example, if you have like this figure, if you drop a ball here, if you displace little bit, it will come down. Yes or no? If like this, you displace it, it will come again. Yes or no? It is stable and it is unstable. Both are in equilibrium. You can put a ball here. Na? Yes or no? After it will come down. Means it is an unstable equilibrium, but it is stable equilibrium. Same way, it is in stable or unstable? Stable why? Because I will displace. Yeah, although it will come up, but it can't come down. It will just oscillate. Yes or no? Oscillate now. I will calculate the time period. That's true. Okay, because it's in stable equilibrium, there will be time period na, for oscillation. Yes or no? But in unstable equilibrium, there can't be oscillation. Imagine, come down na, and again it can't come here to this point na. Yes or no? In stable equilibrium, there is oscillation. SHM will be there. Stable equilibrium. Yes or no? Okay. This is condition for stable equilibrium is F should be equal to mg. Yes or no? Yes. Now, can you please calculate the what is happening here? If I am displacing it a little bit, it will have SHM. Yes or no? Can you calculate the time period of this oscillation? I already gave you hint to calculate. Yeah. Do you remember this equation? d2y upon dx square plus this is t in terms of t, just d square x upon dt plus what was this? Omega square x equal to 0. Do you remember this? And one more thing I have given. If acceleration is equal to minus omega square x, do you remember? What is this? This is acceleration, na? This is acceleration, na? If I took this there, this will become this or no? Yes or no? And one more thing I have given. If I will multiply with m both sides, it will become minus kx actually. Yes or no? For SHM, remember 3. You can apply any one. Always try to apply this one so that you can have correct answer. This will also have correct answer, but what is K? You don't, but you know. K is what? Spring constant in spring. But everywhere compare spring constant to that equivalent physical quantity. What is that? I don't know. Just comparison purpose. You will have you can compare using this. Now you solve this. I already solved 1 or 2 questions in the classes. Yes or no? Calculated time period na for charge particle suspending. I calculated this. Using that concept, can you calculate? I will do it, but first try. You try. I want you to use this concept always, because in every chapter you will have SHM in every chapter, and you will have to calculate time period of that SHM. This is the favorite question of any examination. If there is SHM, they will ask for time period. Okay, should have any idea na? Okay, calculate this. In rough page, in rough copy. If the direction of current is same, then what will happen? Stick to each other, yes or no? And will they fall down? No. Why? At this point, if they will stick, but it will not return here. If the weight of this is greater, means here the force will be lesser, na? Now it will come down, and at a certain height, it can't go beyond that. After certain height, it can't go beyond that. Why? Because force, again, attractive force will be equal to weight of this. Why? It will suspend here. Yes or no? Here it will suspend, but it will be in unstable equilibrium. Why? After going just below that, mg is equal, na? Mg is not going to change or greater or less, but F decrease, na? Because of distance. You increase the distance, it will come down. It will be unstable equilibrium. It is stable. But I will talk it later. First do it. Okay, no problem. I'm solving. Don't waste your time. Okay, everyone. This is the last time I am solving for time period. You will have to solve it. Again, if it comes, you will have to solve it. That's why get by heart what I am applying here. Okay. Listen. What is there? What I already told you. Always calculate the force that want to retain its position. What is the force that make it retain in its position? I want to displace it just little bit. Means I just displaced it what? X distance. Now the virtual wire is in upward direction. Means this is at X distance. Clear? I displaced it X distance. Clear? Is this okay? And then now it will oscillate like this, no? Yes or no? Okay. When wire was in this position, it were attracted by this force, no? Because it wanted to bring it down. Yes or no? What is greater here? Mg is greater here. Yes. Means it will come down. Means Mg will be greater, no? Yes or no? Means restoring force. Restoring force. Here, this is restoring force. Clear? Yeah. गया तुम्हारा time period. This is restoring force. Means what? Mg minus F. Yes or no? Tell me. At equilibrium, it is what? At equilibrium, F equal to mg. Yes or no? Means what? F is what? Already told you, mu naught I1 I2. I1 I2 means I square. L length of this wire. Yes or no? Capital L upon 2 pi d means h, na? Yes or no? This is the formula equal to mg. Remember this. Okay, this is for equilibrium condition. Now this is not in equilibrium. Means mg minus f. Yes or no? F what? At x distance, now x plus h. At h plus x distance. Yes or no? Not this f. This f is at what? H distance. Yes, no? What will be the formula? This is mg, no problem. What will be this? Mu naught I square upon into L upon 2 pi h plus x, no? Yes or no? Yes or no? Good. Mg minus, tell me, mu naught I square L by 2 pi. Mu naught I square L by 2 pi equal to what? Mg into h. Mg into h. mgh. This term divided by what? H plus x, no? Yes or no? Tell me. I took this term equal to what? Is this same? Yes or no? Multiplied with this mgh. Yes or no? Divided by h plus x. Clear to everyone? Okay. This is restoring force. Clear? This should be equal to minus kx. Clear? Minus. Okay. Let's calculate this. Now this, listen. mg in both. Yes or no? And 1 minus h by h plus x. Okay. Now x is very small now. X is very small. If x is very small, okay, x is very small. This is minus now. Okay, consider it like this: mg h plus x minus h na divided by h plus x. Yes or no? H got cancelled. Yes or no? Cancel now. What will be this result? mg x na by what? H plus x. Yes or no? Tell me. Yes. If x was very small or no? X was very small na? Very small displacement. Can I neglect this here in compared to x? H. No? Yes. Yes. X was very. Always remember this. SHM will happen when displacement is very small. If displacement is greater, it is not possible. But SHM is the special case for periodic motion. Yes or no? SHM is the special case actually. Clear? I will teach you in SHM. But SHM is only for small displacements. Clear? Okay. This is SHM. That's what I can neglect it. Means for. Remember this and always use this approach. Always this approach. Use this approach to find time period. And remember how I get it. I want always find the restoring force first. Clear? Find the restoring force. This is restoring force. I am finding F restoring equal to what? mg x by h for what? When h is greater than x. Yes or no? Yes or no? mg by h equal into x. Because it is restoring the. It is what? Restoring. Restoring force should be negative. Yes or no? Tell me. Why? X was a positive. If I am taking positive, upward positive, downward negative. X is upward or downward? I took x now. I displaced upward means I took positive displacement and force is in which direction? Downward. It should be negative to x or no? It should be opposite to x or no? Yes or no? That's why I will use negative sign in every way. Because it is restoring force, it will have negative sign. Yes or no? It will have negative sign. Clear? Now, is it following this relation F equal to minus kx? This is k, this is minus, this is x. F restoring. This is what? F restoring equal to minus kx. Yes or no? This is equation 1 and equation 2. Comparing equation. This is standard form of SHM actually. Clear? This is SHM. Clear? Comparing both equations. Comparing both equations. K equal to what? mg by h. And in time period, when you will have calculate time period, it will be for spring. I will teach you. It will be 2 pi root under m by k. M by for spring. This was for spring, na? I told you, na? Compare only k. This was the comparison, na? In place of k, what is there? This for spring, the time period was 2 pi root under m by k. Means we will put the value of k here, na? T equal to 2 pi root over m. M is what? M is m, mass. What about k? K is mg upon h. Yes or no? Mg upon h. Mm will cancel. H will come up here or no? H will come up now. Time period T equal to 2 pi root over h by g. We got the answer. Clear? This is the time period with which it will oscillate. It will oscillate. Clear? Clear to everyone or no? Tell me. This is the time period with which it will oscillate. Or you could have applied more. You could have mass into acceleration. You could have applied that too. I am approaching with first copy this. I will approach with second one. Copied? Okay. Now I want to give you second method. What is that method? Let me. Here. Oh, sorry. Okay. This was the equation for force, no? Is this equal to mass into acceleration? Force is mass equal to acceleration because restoring force, again negative sign will be there. Negative cancel out each other. Because I already told you if it is restoring, it will be minus m. Force will be in the opposite direction of acceleration or displacement. Minus mg by h into x. Clear? Yes or no? Mm. It is what? A equal to, actually don't write because negative sign already have given here. Don't write negative. Here, what is this? Minus omega square x. This is standard equation for SHM, na? Yes or no? And we obtain this equation. What is this? A equal to g by minus g by h, na? Into x. Yes or no? In place of omega square, what is there? Equation 1 and 2 means 2 and 3 just comparing 2 and 3. What is there? Omega square equal to g by h. Yes or no? Okay. H. What is omega? Root over g by h. Omega means 1 by 2 pi, means 2 pi by t, na? Yes or no? Root over g by h. Now I want to calculate t. What is t actually? T will means reverse them. And 2 pi root over h by g. We got the same result or different? Same result, no? I taught you this one. Already I had wrote these three forms, na? Here d2. There are three forms. d2 y not y x upon dt square plus omega square x equal to 0 or a equal to minus omega square x or f equal to minus kx. Whatever form you find, compare with them. Yes or no? First, I solve with this. Second, I solve with this. Yes or no? I did the same, no? Okay. Copy this in second method. Writing second method. after the first method, second. Now what? Everyone, what is that? I told you that there will be two cases. Now, one is up, means let's say this is the infinite current carrying conductor. Okay. One more conductor is there of finite length. Okay. Of length L, mass M. Okay. Now, tell me the direction of this conductor so that it will suspend. Tell me the direction. Same or opposite? Same. In the earlier case, what was the direction? Opposite. Yes or no? Because in that case, you wanted to repel it so that it may suspend. Yes or no? In this case, you want to what? Attract it now. That if there is a repulsion, then it suspend. No. It will come down. It will fall down. That's why you need same direction here. If this is I, this is also I. Is this stable equilibrium? Now the force is same. mg is downward and F force means magnetic force is upward. Yes or no? What is this magnetic force? Mu I square upon I square L, length of this wire, upon what? 2 pi h, or let's say d. Depth na? Downward this. That's why you can consider d. Okay, depth. Yes, downward. Yes or no? Now, these forces should be for. Is it unstable equilibrium? Unstable equilibrium. Is it? This is what? Unstable equilibrium. Equilibrium. Okay. Means FB will be equal to mg, and this mu naught I square L upon 2 pi d equal to m. Yes, na? Means weight of the wire should be equal to magnitude of the force, attractive force. Clear or no? This is unstable equilibrium. That's why there will not be SHF. Yes or no? The wire will not follow SHF. Why? Imagine. If I'm displacing this wire slightly, little bit, F will decrease, no? T increase means F will decrease. Is there any decrease in magnitude? Actually, mg will all slightly increase. Coming down, velocity of g, value of g will increase. Means force in downward direction got increased. Will it come back at that position? No. It will come down again and fall down. Yes or no? Means there will not be stable equilibrium. That's why no SHF will be there. Clear no? Clear? Why SHF is not there? Okay. Perfect. Okay, this. If a wire is like this, closed loop, it is placed in uniform magnetic field. Tell me the force on this loop. I current is flowing. Tell me the force. What will be the force on the loop? Force. I'm talking about force. And both are what? I'm talking about force. Don't get confused. Force. What will be the force? This loop is inside in a uniform electric field. Okay. What will be the force? 0. Why? F equal to what? IL cross B na? Ideal cross B. Yes or no? What is this? DL now? Okay. What is DL here? 0. Why? Vector quantity. Yes or no? Initial and final same now. Take this initial And final thing, what is dl? I already told you na, we will take displacement. Yes or no? In loop, displacement is 0 na. That's why it is 0. The force will be 0. Yes or no? Means in a loop, in a uniform electric field, what is the force acting on it is 0. Clear? A loop current carrying loop in a uniform electric field will experience 0 force. Clear? Clear to everyone? Okay. What is the definition of ampere? Ampere? Actually, ampere is nothing. Okay, is the unit of current, na? In ampere, definition it is actually. Why it is 1 ampere? What is 1 ampere actually? What is 1 ampere actually? Actually, it is the force acting through current carrying straight wires, infinite straight wires, when they are separated by some distance. What is the distance? Means 1 meter. Okay. What is the distance? 1 meter. And straight wires were carrying what? Current? 1 ampere. 1 ampere. 1 ampere. And the force between them should be what? Let's calculate the force. And that force, when this force will act between this wire, then the current will flow what? 1 ampere. Yes or no? What will be the force? Force on is this or this? Anyway. Force per unit length actually 1 meter, na, it is. Means sorry. For force per unit length. Force on either wire. Let's say about this wire. What will be this force? Mu naught I1 I2 upon 2 pi d. But what about length? Length per unit length. Take per unit length. Because I already told you, if you are not taking per unit length, it will have same different forces. Yes or no? Okay. This should be equal to what? Let's calculate. What is this? 4 pi into 1 ampere into 1 ampere. Yes or no? Divided by 2 pi into d. D is 1 meter, na? 4 pi to 10 to the minus 7 is also there, na? 1 into 1. Yes or no? 2 pi, 2 pi. Means 2 into 10 to the power minus 7 Newton per meter should be there. Yes or no? Yes, na? When this force acts between these two parallel conducting wires, then the current will be of what? 1 ampere. This is the definition of ampere. Yes or no? Ampere definition. Don't need to write. If you understand, it's okay. You can write that when the force between them is 2 into 10 to the minus 7 Newton per meter, then that both the wires will conduct how many current? If you can copy, you can copy. Otherwise, it's okay. There is no concept behind this because these are theoretical things actually. Okay. Now another question have concept. Here I have two charges. Okay, I have two charges, two positive charges actually. Okay, tell me, they are moving with velocity v. Let's say with velocity v. What will be the forces between them? There are how many forces will act between them? What is the forces? Electric force and magnetic force. Yes or no? They are moving with velocity v na? V na? They will have magnetic force. Yes or no? It will have magnetic field on this. If a charge is moving on in a uniform magnetic field, it will have force. Yes or no? Means they will have magnetic force, and because they are charged, they will repel each other. Na? Yes or no? Due to magnetic force, is it attracting each other or not? Will they attract each other? Yes. Or repel each other? Imagine which will be the direction. I'm telling you, don't worry. Understand with me? Due to this, where will be the magnetic force? Magnetic field actually first. I already told you in Biot-Savart law. What was that? dV equal to mu naught I dl sin theta upon r square, right? Like this. Yes or no? I make it q. What I made it dl by dt. I made it v. Yes or no? What was the formula? I got mu naught q v upon r square. No? नहीं 4 pi was there also. No? 4 pi. अच्छा mu naught upon 4 pi ना? Yes. 4 pi r square. This was v ना? Okay. Tell me what should be the direction? What was the direction here? Perpendicular. This was actually ideal cross r na. Vector form of Biot-Savart law. Cross r means it should be perpendicular to r as well as current. Ideal. Means dl is in this direction na, and r is in this direction na. It should be perpendicular to both. And in which direction ideal cross r na? Yes or no? B will be in this direction only. Yes or no? Or in this. This will also have the same direction. Let's talk about this. This V, due to this, the magnetic field force field here will be in this direction now. Due to this, I am calculating due to this. Yes or no? Let's say this small section. It is moving now. It is moving. That's why it is V now. Okay. It will be coming out. Okay. Now the magnetic field here is coming out. V cross B now. Let's talk about force. V is upward. B here means force on it is in this direction. This is FB now. Yes or no? And what is FB? Means what will be FB? Okay, let's calculate. Means magnetic force now. FM. Not FB. Magnetic force. I'm giving FM. What will be this? I literally Q into V cross B na? Q V B. What is B? Mu naught Q V upon 4 pi r square. Yes, this is V, and both will have same magnitude because both are at same distance, same quantity Q, same V. Yes or no? And Q mu naught Q V square upon 4 pi r square is the magnetic force. What about electric force? K 1 by 4 pi epsilon naught Q square upon r square. Yes or no? Yes or no? This is attractive. This will attractive, and this is repulsive na? Why attractive? I told you na, force is in this direction. It will also have same direction na? Imagine IL cross B, IL cross R actually, IL cross R, ideal in Biot-Savart law. R, it will have opposite direction draw. It will have inside na, inside B is inside, V cross B, force is this side na. Yes or no? They will attract only. Means like current carrying wires are not. Yes or no? Current carrying wires means same direction will attract, opposite direction will repel. And due to electric force, this is repulsive now. Electric force is repulsive because both are of positive charge. What is this ratio? Fm by Fr. What is this ratio? What will be this ratio? There are Q square, na? Yes or no? Q square, R square cancel. Yes or no? V is also there, na? Yeah, V is there. V is there, no? Yes. Means this is what? Mu naught upon 1 by 4 pi means mu naught into, okay, this one mu naught upon 4 pi into V square, na? Divided by what? 1 by 4 pi epsilon naught into nothing. Clear, na? Let's divide it. Yes or no? Let's divide it. It will come up. 4 pi will cancel, na? It will come up. Mu naught epsilon naught V square Fm by Fr. And mu naught epsilon naught is in electromagnetic waves. I will teach you. C equal to 1 by root over mu naught epsilon naught. Okay, I will teach it. Mu naught epsilon naught. C equal to what? Mu naught epsilon naught. Yeah, this is correct. Mu naught epsilon naught. Okay, I will take this in electromagnetic wave. Okay, and C is also equal to what? E by B. How many of you remember this equation? Do you remember? Always remember. Whatever I'm giving you hint inside, this is very important actually. You should remember that. Always copy those things whatever I'm writing inside. It is more important than what I'm teaching. Okay? Because these are the things you will see repeatedly, and these are the things in examination then they can be asked. In this ratio, you will have questions. What is C equal to? C is what? What is C actually? Speed of light. Okay, speed of light. And it is equal to 1 by root under mu naught epsilon naught. Mu naught is what? Magnetic permittivity. Epsilon naught is what? Electric permittivity. E is what? Electric field. B is what? Magnetic field. What is there? Forces are there, no? I took ratio of them. Now, what will be this? 1 by C square. V square upon C square. Means, I am writing it. V square upon C square. Finally, we got this result. Fm by Fr equal to V square upon C square. Copy this. Fe, not Fr. If I will take E upper side, E, it will be C square by V square or no? If I am taking F E by F M, it will be C square by V square. Speed of light, square of speed of light by speed of charges. Clear? Okay, now proceed to the next chapter. Oh, it's time. Okay, solve a question. No problem. Solve a question. I current is flowing. R total force on the whole wire is. Okay. Solve a question. I will not do theory part. Solve a question. This is semicircle. Okay. Radius of this circle is R. Okay. What is this radius? R. This is also R. The length is R. Okay. What is the current passing? I. And the magnetic field is here into the plane. Okay. Uniform magnetic field is there. Tell me the force. F. What is the magnetic strength intensity? B. Okay. B is the magnetic field I is the current, R is the radius of the wire. This is the wire actually in this form. Current is flowing like this. Okay, clear? Tell me the force, magnetic force acting on this wire. Magnetic force acting on this wire. Find, I'm writing, find magnetic force on the wire. What is L there? 4R na? Length of the wire. I will take displacement whether it is curved or not. I don't care. I will take the initial and final. Yes or no? What is the length between initial and final? 4R. 2R is there in between them. And R, 4R. B is magnetic field. What is the formula? PIL sin theta. Why sin 90 is there? Because magnetic field is perpendicular to this plane. Yes or no? Yes. That's why 90 will be there. BIL. BI and L is what? 4R. 4BIR. What will be the answer? BIL sin 90 degrees. B is same, I is same in place of all. L, there are 2R. Yes or no? 4R. Sin 91 means 4BI. Yes or no? What will be the direction? What will be the direction? Tell me. It is also important, no? Huh? What will be the direction? Outward or upward? Upward will be there, not outward. Outward is wrong answer, na? Outward means you are talking about away from the plane. Yes or no? It is not away from the plane. It is upward to the plane. Imagine IL cross B, na? What is this formula? IL B. What is this? IL cross B, na? Yes or no? I will take IL first. IL. B is inside, na? I will curl the finger in this way. Means upward. Clear? Upward is the direction. Means upwards. And direction is also important because in the question magnitude and direction both can be asked in the objective question. This will be given in all the 4 options, and the direction will be different: upward, downward, away from the plane, down toward the plane. We'll have to distinguish. Means you should know both these things. Clear? Okay. This is all about today. Thank you for listening.